Welcome back. This is chemistry question 41 from IMAT 2015 past paper. So I'll be solving this question. It says 0.75 grams of hydrocarbon compound contains 0.6 gram of carbon. So which one of the following could be the molecular formula of hydrocarbon compound? So we're asked to find out the molecular formula for this specific compound, the hydrocarbon. So we're given with the mass of hydrocarbon compound, and the mass of single element, which is carbon, and the atomic masses. So with this given data, the only way to find out the molecular formula is using the empirical formula method. Empirical formula. So this is basically the simplest ratio. So the simplest ratio of a compound. So what we're going to do is, first of all, we need to know that in a hydrocarbon the main elements is in a hydrocarbon. So in a hydrocarbon compound the main elements is. Welcome back. This is chemistry question 41 from IMAT 2015 past paper. So I'll be solving this question. It says 0.75 grams of hydrocarbon compound contains 0.6 gram of carbon. So which one of the following could be the molecular formula of hydrocarbon compound? So we're asked to find out the molecular formula for this specific compound, the hydrocarbon. So we're given with the mass of hydrocarbon compound, and the mass of single element, which is carbon, and the atomic masses. So with this given data, the only way to find out the molecular formula is using the empirical formula method. Empirical formula. So this is basically the simplest ratio. So the simplest ratio of a compound. So what we're going to do is, first of all, we need to know that in a hydrocarbon, the main elements is in a hydrocarbon. So in a hydrocarbon compound, the main elements is the carbon and the hydrogen. So these are the main uh, elements. So for the carbon, we are given with 0.6 gram mass. So we know for empirical formula, we just basically have the table like this. So this one, going to draw this table real quick. So in this empirical formula method, we're going to use one main formula, which is basically the moles is equal to mass by the air, which is the most basic formula we're going to apply here. So drawing this column for separate element, which is carbon and hydrogen. So we have carbon and hydrogen. So we'll have the mass over here, the air, the atomic mass, and the moles, and we'll have the simplest ratio. So we're given with the mass of the carbon only. So to find the mass of hydrogen, just we're going to subtract the mass of the hydrocarbon 0.75 from 0.6 grams. So this will give us
0.15 grams of hydrogen. So now we have the mass of hydrogen. So we're going to simply divide by the atomic mass. So the given atomic mass is the 12 grams per mole, and for hydrogen it's 1 gram per mole. So we'll divide 0.6 divided by 12. So this will give us 0.05 moles, and for the hydrogen it's simply going to be 0.5 grams, 0.15 grams. So we can now divide the number by the smallest number. So we know the smallest number is 0.05. So we're going to divide both sides by 0.05. So this will give us 1, and 0.15 divided by 0.05 will give us 3. So now from this, our empirical formula for this compound and their given masses is C1, 1 carbon and 3 hydrogens. So now we're going to look in the options. So it seems we do not have any options that display this answer. So what we are going to simply do is just increase by factor 2. And so we get 2 carbons and 6 hydrogens multiplied by 2, 6 hydrogens. So now we'll look for the option. So it's option C, which is 2 carbons and 6 hydrogens, which is the most likely the molecular formula of this hydrocarbon. So that's how we solve this question. I hope you find this video helpful. So please leave a like and subscribe to my channel. Thank you guys. Bye. Okay, welcome back. This is chemistry question 42 from IMAT 2015 past paper. So I'll be answering this question with full solution and working. So in the reaction, 24.6 gram of 1 bromopropane reacts with excess potassium hydroxide to produce 8 gram of propan 1O. So we are given with the balanced chemical equation. So we know that for each species it's 1-to-1 ratio. So for overall reaction it's 1-to-1 ratio. So we're given with the MR of each elements and species, the compound. So the question asks, what is the percentage yield of this reaction? So we know our primary focus is on about the yields, percentage yield of propane 1O, our main product that is produced. So this one right over here. So, and we are given with the masses and data for 1 bromopropane and propane 1O. So for these two species, so we know the reactant and product, we have 1-to-1 ratio between them. So we can directly place any moles calculated and directly substitute in that species without need to worry about whether we have to divide or do anything since they're 1-to-1 ratio. So let's begin. So we have this given data, we are going to use that. So the main formula we're going to use throughout is basically the moles is equal to mass by AR or MR, depending if it's element or compound. So this is the main formula we're going to use, and the formula for percentage yield is percentage yields is equal to the actual yields, the actual yield divided by theoretical yield times 100. So this is the main formula for this percentage yield of reaction. So we know the actual, so what's the value for the actual yield here? So we directly know it's 8 grams of propan 1O since we were focused about only the product propanol. So it's 8 grams and we're focusing this on propan 1O. So That's also now we have to find the theoretical mass of propan 1 ol or yield. So theoretical yields. So for that we are going to use the mass 1 bromopropane, the 24.6, and divide by its molar mass, which is 123. So the moles of 1 bromopropane is equal to 24.6 grams divided by 123 grams per mole. So this will give us 0.2 moles. So now we know it's a 1-to-1 ratio. So the moles of propan 1 ol is equal to 0.2 mole. And so now we will convert and we'll find the mass, the theoretical mass of the propan 1 ol. So we're going to simply use this formula as we did for this one for finding the moles of 1 bromopropane, and then we simply multiply 0.2 moles with the molar mass of propan 1 ol. So since they've not given us, we're going to use this atomic masses of elements to find out. So the atomic mass, the MR for propan 1 ol is 3 times 12 plus 7 hydrogens, 7 times 1, and then, oh sorry, it's 8 since we have OH, so we're going to add that, and then plus we have 1 oxygen, so that's 16, so this will give us total 60 grams per mole. And now we are going to directly multiply mass of propanol, propan, sorry, propan 1 ol. So that's 0.2 times 60. So that will give us 12 grams. So this is now the theoretical mass of propan 1 ol. So now we're going to substitute the value 12 grams here in the denominator and the 8 grams in the numerator, and then find out percentage yields. So finally, the percentage yields is equal to the 8 grams divided by 12 grams times 100. So this will give us the percentage yield 66.7 grams. So that's our final answer. So the only correct option is option E. So that's 66.7. So that's how we solve this question. And remember that there's no calculators allowed. So you're going to have to divide manually, like using this method where you put this inverted L over here and then you put 8 and then 12 outside, and then you put this decimal and then you continue dividing till you reach the point where you may finish. But since this is infinite number because the actual value is 66.666, so it continues forever. So you just round it off to significant at least one decimal place to get 66.7. So this is the answer. So that's how we solve the question. So thank you guys for watching my video. I hope you find it helpful. Please leave a like and subscribe to my channel. Thank you guys. Bye. Okay, welcome back. This is question 45 from chemistry section in IMAT 2015 past paper. So I'll be solving this question. It says atoms X and Y form an ionic compound with formula XY2. Which option could give the correct atomic numbers for X and Y? So they've given us the atomic number. So first of all, we must know that atomic number, in other words, it's also called proton numbers, the number of protons. So in a neutral atom, the atomic number or proton number is equivalent to number of electrons number. So they're equivalent to each other. So for example, if we say the atomic number of an atom is 3 or 2, so the number of electrons will also be 2 and 3, given that the atom is in its neutral state, it hasn't lost or gained any electron, so it's not an ion, it must be a neutral atom. So this is the first thing we should know. And secondly, for an ionic compound, we know ionic compound is mainly formed from metal, between metal and non-metal. So there's huge electronegativity difference between these two species. And we know metal loses electron to form cation, and non-metal gains an electron to form an anion, which is the negative charge, and here it's positive charge. Okay, so that's the thing we must know about ionic compound. It's mainly formed between metals and non-metal compound. So now the given compounds, the ionic compound they gave us is X, Y, 2. So we have 2Y atom bonded to this 1X ions. Okay, so what we can do is that we can separate this into ions. So this will give us X with 2 plus and Y with negative charge of minus 1. So we know if we swap these charges together, it will give us X and Y2. So why is that? To balance the overall charge so that it is neutral compound. Okay, so if we separate, this X must have a positive charge because it has lost 2 electrons. So we have also the Y ion, it has negative charge. So there must be 2Y compounds. So total 2Y compounds to gain 2 electrons from this cation X to balance the overall charge. Okay, so these are the ions we must know. So this means it has lost 2 electrons and it has gained 1 electrons. So gained and lost. So this means if we were to construct the electronic configuration, the very simplified electronic configuration, this means that, for example, the innermost shell of electron must have 2 electrons. Here it might have 8, 8 and 8 and so on, but the outermost electron must be 2 of them. And for Y, the innermost will be 2, and then it could be anything, and the last must be 7. So why? Because it will gain 1 electron to form 8 over here, the outermost shell. So this will complete its octet rule because it has 7 at the end. So what we also know about this, that since the it loses 2 electron, it forms oxidation state of 2 plus. So this must be group 2 metals, which is an alkali metal, and this Y must be group 7, which is the halogens. Okay, so these are the two uh, atom with its electronic configuration in its neutral state, where it must have these number of electron in its outermost shell. So now we're going to reduce the electronic configuration with these given atomic number, and we know atomic number is equivalent to electron number, so we'll consider all this the number of electron in the neutral state. So what we can identify here is that Okay, so let's go with the basic one. We have x11 and y16. So if we construct for option A, the electronic configuration, the very basic one. So for x, it has 11. Okay, so 2, 8, 1. But we need the last number of electron to be 2. So this option A is also wrong. For B, it's also going to be 2 and 1. So that's also wrong too. And for option option C, if you construct the electronic configuration for X, and since they mentioned 12, so 2, 8, and then this will give 2. The last number of electron must be 2. 2 plus 8 is 10, and then plus 2 gives 12. So this seems to be correct. Now let's make it for Y. So it's 9. So the electronic configuration for this must be 2 and 7. So now this is correct because it matches for working over here that the last electron number for these elements must be 2 and 7 for the ionic compound to be formed as X and Y2. So this is the correct option, option C. So that's why this will lose 2 electron and there must be 2 Y elements, 2 Y atom to gain these 1 electron each to form the compound X, Y2. So option C is the correct option. So that's how we solve this question. Okay, so I hope you find this video helpful. Thank you guys for watching my video. I hope you find it helpful. So please leave a like and subscribe to my channel. Thank you guys. Bye. Okay, welcome back. This is chemistry question 46 from IMAT 2015 past paper. So I'll be solving this question with all explanation. So it says 2,2-dimethyl propane is an isomer of pentane. So we are given with this structural formula for each of these compounds, the isomers. And it says pentane has boiling point of 36 degrees Celsius, while the boiling point of 2,2-dimethyl propane is 10 degrees Celsius. Which statement below explains the difference in boiling point for these two substances? So before we go through each of these options, we must draw some workings so that it will make it easier to solve this question and to explain the difference in boiling points. So first of all, we know that they are isomers of each other. So again, we must recall the definition of isomer. So isomer is a compound which share the same molecular formula, but they differ in structural arrangement. So like one can be branched or one can be linear and whatsoever, but sh- they share the same molecular formula, which is the number of carbons and hydrogens and whatever elements. So we know it's purely hydrocarbon and as it has two main elements, carbon and hydrogen only. So it's mainly hydrocarbon, so we're going to only focus on number of carbons and hydrogens, and they're going to be same, but they have different structural arrangement. So first of all, we have to know the molecular formula of isomer. So we're given with the structural formula, so we can add the number of hydrogens and the carbons, so that this simplifies to give us 5 carbons and 12 hydrogens. So this is the molecular formula of the isomer. Alright, so now we know the molecular formula of isomer. Now we can go to step 2, which is the displayed diagram of isomers. So I'm going to draw the display diagram of these two different isomers so that we can clearly picture the difference in structural arrangement of these two compounds while they share the same molecular formula. So the display diagram. So first of all, it's going to be 2,2-dimethylpropane. So the center carbon is completely surrounded by methyl groups, all the four sides. So this is all the methyl groups. So this is the diagram for 2,2-dimethyl dimethylpropane. And now the second structure that we have, the isomer is pentane. So this is the display diagram. And so the structure is pentane. So now we've drawn the display diagram of these two isomers. So now what we can conclude by observing these structures of these two different isomers is that this 2,2-dimethyl propane is more branched alkane and pentane is more linear structure. So we know both are alkenes and hydrocarbon, but the different structural arrangement. So this first one is the more branched structure and the second one is more linear structure. So this is the different structural arrangement and both has the same molecular formula C5H12. So now we can explain the difference in boiling point for these two substances. So now we can go through each options to explain the difference in the boiling points. So the first option says 2,2-dimethylpropane has stronger intermolecular forces. So now we must know also that both are hydrocarbons and also they're alkanes. So now what we know for the option A, this is explanation for option A. So since they're both alkanes and hydrocarbon, main intermolecular molecular forces formed by these compounds are London forces, or you can call it van der Waals force or London dispersion force. So they're both the same meaning. So London forces. So these are the weak intermolecular forces that are formed within the nonpolar molecules. As we know that these are hydrocarbons, it only has carbons and hydrogens. So these forms only London force interaction since they're nonpolar molecules. Okay, so they form London forces. And since we know that 2,2-dimethyl is highly branched molecule, so it has very small surface area. So what do I mean by that? I'm going to draw the structure here real quick. CH3 or here CH3. Then and then I have the other compounds, the same molecule, the same compound as this one. Okay, so here it can barely form like only two points of contact because it's highly branched molecule. But now if you compare it with the pentane, the interaction formed between them. So pentane, I'm going to quickly draw the skeletal diagram so that it's more shortcut and easier. And also it's highly useful for iMath exam since the time is very challenging and it's only 90 minutes. So you have to solve it very quick. So these are the structure of pentane, the skeletal structure. So these are the like interaction formed. So these are London forces, London forces. So now we can clearly see that these are only two contacts formed, but here we can see that there are around five contacts. So now why is that? Because the pentane has larger surface area, so it has more points of contact so that it can form more number of London forces with the other pentane molecules. But whereas this 2,2-dimethyl since it's highly branched molecule, it can only form very limited contacts with other 2,2-dimethyl. So that's why the boiling point for this 2,2-dimethyl is very less compared to the pentane, since it has very limited contact with the molecules, and so it's easier to break the bonds. So less amount of energy is needed for less number of contacts to break, but whereas for the pentane, there's more number of contact forces, more number of London force of interaction, so more energy is needed to break these bonds. So that's why pentane has greater boiling point. So now moving on to option B. So the molecule have different relative atomic mass. We can straight out say it's no, since we know it's C5H12, so both share the same molecular formula. So option C, isomer have different chemical properties. Okay, so generally we know this is true, but they've said the boiling points. We're talking about the boiling point. This is the physical property, not the chemical property. So that's why we can also directly rule this out. The option C is wrong. So now moving on to option D. Pentane has permanent dipoles. As we clearly said, they're both non-polar molecule. The only forces they form is London forces. Okay, so this is also incorrect because permanent dipoles are formed only in polar molecules. These are hydrocarbons and they're non-polar molecules. So there's no permanent dipoles. And now option E. The longer chain, less branched molecule have stronger spontaneous induced dipole. So this is correct. So they mentioned spontaneous induced dipole. This is also another word for the London forces. Okay, so both are different word with the same meaning. So this is the only correct option as we discussed. The 2,2-dimethylpropane is branched molecule. It has limited contacts and surface area, so it has less number of contacts, so less energy needed to break these few number of contacts, whereas for pentane it's more linear, it forms more number of contacts, so thus it has more boiling point. So this option E is correct only. So that's how we solve this question. So thank you guys for watching my video. I hope you find it helpful. Please leave a like and subscribe to my channel. Thank you guys. Bye. Hello guys, welcome back to my channel. So this is chemistry question 49 from IMAT 2015 past paper. So I'll be solving this. It says when propan 1O is burnt in excess oxygen, the only products formed are carbon dioxide and water. In the balanced equation for this reaction, what is the ratio of carbon dioxide to water molecules formed? So we know this propanol is organic compound. So the general rule for any organic compound in complete combustion is that it forms carbon dioxide and water as a product. So now they're asking the ratio for these products, carbon dioxide and water. So first of all, we're going to write the general formula for this propan-1-ol in complete combustion. It is three carbons. So we must know the formula for propan-1-ol. So prop means three carbons. So three carbons, and there are eight hydrogens and one oxygen. Since it's an alcohol, so plus it's burned in complete combustion. So there's excess oxygen. So we're not going to first write the balance equation. We're just writing the general chemical equation. And then as these main products, carbon dioxide and water. So now we're going to balance this chemical equation. So we know we have three carbons this side, so we're going to like use priority rule. So we're going to first prioritize the number of carbons, number of hydrogens, and then number of oxygen. So I have three carbons in my reactant side. So I'm going to add three over here and eight hydrogens. So I'm going to add four over here. So now to balance for oxygen, I have 3 times 2 oxygen plus I have 4 oxygen. So this will give me total. So 12, sorry, 6 plus 4, this will give me 10 oxygens. So to balance this chemically, I'm going to write here 9 by 2. So because it will cancel out with this 2 oxygen. So now if we try to balance, 1 oxygen plus 9 by 2 of this 2 oxygen, and this will give me 10 oxygens. So this is my balanced chemical equation, the simplified. Because now if we try to uh, make this as, we can cancel this 2 out by multiplying 2 by both sides. So if we multiply everything by 2, we're going to get 2, 2 propane 1O plus 9 oxygens. This will give us 6 carbon dioxide and 8 water molecules. So, but we already know that there's none of the given options that states this ratio. So what we can do, we already know if we divide this by 2 back, we'll get this ratio, 3 carbon dioxide and 4 water molecules. So now in our given option, option D is correct because this corresponds to our working 3 and 4 in the simplified ratio. So option D is the correct option, 3 and 4. So that's how we solve this question. Thank you guys for watching my video. I hope you find this helpful. Please leave a like and subscribe to my channel. Thank you guys. Bye.
Yeah.